Alright, ladies and gentlemen, you're watching Forces 1, Lesson 5.1, How is Velocity Different from Speed? You're going to be using a Venn diagram, so a quick review, it should be the one that looks like this. It's got two circles, and we got the differences on the outside and the similarity in the middle. And so your job is to figure out how they are different and also how they're similar for those things for the Venn diagram. So as a quick review, what is speed? Well, speed is simply a rate that describes the distance traveled over a specific rate or amount of time. And so our formula for it is distance divided by time, or dt, or you also know it as d divided by t. And so we have these different units that are involved as well. We got feet per second, we got miles per hour, kilometers per hour, inches per second. And so some basic units that you might see is like 30 miles per hour or 12 meters per second. You're going to be seeing those types of problems throughout our unit, and you'll see those types of units throughout our next unit, Forces 2, when we talk about momentum, acceleration, deceleration, and those other things involved. The next thing you're thinking about right now is, well, what is velocity, and why do I care? So, I mean, this part here, you know, we've heard velocity as a term before for different things, from football, people hitting people and stuff, or cars traveling at a different velocity, or roller coasters as they go, and then you might see just some different things. But what is this term velocity here? And so we're going to take a look at that and demystify that term in our lesson today. Well, what is velocity? Well, velocity is simply just speed, but in a specific direction. So you got north, south, east, and west. You also got, the other ones, northeast, southeast, southwest, and all that stuff. But basically, it's the same formula for speed. Same as speed, but you're adding a direction. And the way we write that out is we look at, we have miles per hour, but we have a bracket here. And so that bracket just simply tells inside what is our direction. So north. And so we always put our direction that we're traveling in, whatever the speed is traveling in a bracket. We saw this a little bit with forces where I did that as well. But let's say we have, a car traveling 30 miles per hour. But the difference is it's traveling east. Or 12 meters per second south. It's very important for that distinction. Well, why would it be important for that direction? Why would I care about an object's speed and its direction? Well, I mean, in football we see that quite often. That direction matters. Wherever the football goes, or down, or left, or right, tells us, the difference between a touchdown and a touchback, or a safety. And so here with football, it matters. We see it with trains. You got to know which direction you're traveling, and backwards and forwards. In baseball, that's the difference between a foul ball and a fair ball. Or in cars, that's the difference between a safe drive and a car crash that we have there. So as you can see, velocity is important. And the big thing to remember is that velocity is directional. Very important to remember that. For the remainder of our time, we're going to be looking at problems that are very similar as speed and velocity, what we did in 4.1, 4.2, and 4.3. But we're simply going to be looking at and identifying, is it speed S or velocity V? Okay, and so just remember, the same formula is used for speed and velocity, and that's distance divided by time. The only difference for speed and velocity is that velocity has direction involved. And so if I see a direction that an object is traveling, I know it is velocity here. If not, I know it's speed. So let's take a look at the problem here. Julia was traveling west on 772 on her bike while listening to her radio, her invention that she made. She traveled 12 miles in 0.6 hours. I look here and I see that she is traveling west. It is a specific direction, so whatever my label is going to be, it's going to have that west portion there in brackets, so I know it will be a velocity problem. Grant is also walking west to CA class, so he's going to have a bracket in west for whatever direction, and it's going to be feet per second. I'm not going to worry about the problem here. We know how to calculate speed by doing distance divided by time. You guys will do that on your own, but we have the velocity because we know the direction. This third problem here, I'll allow you to read it. These maglev trains are the fastest in the world. They travel 1,162 miles in only 2 hours. How fast can these travel? I don't see direction. And so, since I don't see it, it is speed, not velocity. So I'm going to put a big S on the left-hand side, and I don't have to worry about that bracket. Don't worry about it, because there is no direction. So this is how you calculate, this is how you do your speed versus velocity problems, and it also gives you the difference between speed and velocity. So make sure you complete your Venn diagrams and then do the practice problems that accompany this video.